the last class we are solving problems on implicit differentiation. So we have solved all the problems from the textbook. In this class we are going to solve few more problems, additional problems on implicit differentiation. So you know the definition of implicit functions. Implicit functions are the functions in which y is not directly expressed in terms of x. Like we have examples, x squared plus y squared is equal to a squared, y squared is equal to 4ax, and so on. Let us consider the problem. So it is given y is equal to root of x plus root of x plus root of x, etc. Prove that dy by dx is equal to 1 divided by 2y minus 1. This is what the function requires. See here, y is equal to root of x plus root x plus root x plus root x. It can be taken as y. When we square it on both sides, you will be getting y squared is equal to x plus 1. You need to understand this step. What is y? Root of x plus root of x plus root of x, etc. up to infinite terms. We write the first term and then look at the expression, it is y. So differentiate 2y into dy by dx is equal to 1 plus dy by dx. 2y into dy by dx minus dy by dx is equal to 1. So we can take dy by dx as common factor into 2y minus 1 is equal to 1. What is dy by dx then? This 1 divided by 2y minus 1. Hope you have understood this problem. Similarly, we will take one more. Y is equal to root of, it is log x plus root of log x plus root of log x, etc. up to infinity. Prove that dy by dx is equal to 1 divided by x into 2y minus 1. That's what you are required to prove. So, you etc. it is given. Y is equal to root of. You look at the second term from second term onwards. Root of log x plus root of log x plus root of log x. It's gone like this. That is, if we have root of log x plus root of log x, etc., that can be taken as y. If you square it on both sides, y squared is equal to log x plus y. Differentiate, derivative of y squared is 2y. 2y into dy by dx is equal to 1 by x plus dy by dx. So 2y into dy by dx minus dy by dx is equal to 1 by x. Take dy by dx as common factor. This 2y minus 1 is equal to 1 by x. What is dy by dx then? Dy by dx is equal to 1 by x into 2y minus 1. That is the answer. Hope you have understood both the problems. So when write the first term and then root of log x plus root of log x plus root of log x, that is nothing but y. Can observe here, if you have x, what is the derivative of x? It is 1 divided by 2y minus 1. Here you have log x. Here log x derivative is 1 by x and 2y minus 1 is common. Let us consider one more problem. Y is equal to then given y is equal to root of sin x plus root of sin x plus root of sin x, etc. Then prove that dy by dx is equal to cos x divided by 2y minus 1. Log x means its derivative 1 by x. Here sin x you have, its derivative is cos x. So y is equal to root of, can take here sin x plus y. Hope you have understood this. Root of sin x plus root of sin x plus root of sin x is nothing but the expression y. This we have got many number of terms. Even if you leave one term, there is no problem. All other is taken as y. If you square it on both sides, y squared is equal to sin x plus y. Square cancels. Differentiate 2y into dy by dx is equal to cos x plus dy by dx. So 2y into dy by dx minus dy by dx is equal to cos x. Now we take dy by dx as common factor. 2y minus 1 is equal to cos x. What is dy by dx then? It is cos x divided by 2y minus 1. I have observed here derivative of sin x is cos x and 2y minus 1. So looking at that expression, I write in general, if y is equal to root of f of x plus root of f of x plus root of f of x up to infinity, then dy by dx will be f dash of x divided by 2y minus 1. That's what the important expression is. Hope you have understood this problem. So we'll generalize and write. This is one of the important questions you need to remember. Hope you have understood all these three problems. It's given if cos y is equal to x into cos of a plus y with cos a not equal to plus or minus 1, prove that dy by dx is equal to cos squared of a plus y divided by sin a. Cos squared of a plus y divided by sin a. That's what you need to prove. So here cos y is given as x into cos of a plus y. So I write x. X can be written as cos y divided by cos of a plus 1. Hope you have understood this. Here x is in terms of y. Cos y is equal to x into cos of a plus y given. Define what is x. Cos y divided by cos of a plus 1. To differentiate with that with respect to y. Because x is a function of y, you differentiate that with respect to y. So what happens when you differentiate RHS? Quotient rule, denominator d by dx of numerator. What is d by dx of numerator? It is minus sign. Minus numerator cos y, d by dx of denominator, minus sign of a plus y, divided by denominator the whole square, cos of a plus y the whole square. Now I write it as cos of a plus y into minus sign. Minus into minus plus, you get sin of a plus y into cos y divided by, I shall write it as cos squared of a plus y. See here which formula? It is of the formula sin a cos b minus cos a sin b. So sin x cos y. In place of x we have a plus y. In place of y we have y only. This can be written as sin of a plus y minus y. Sin x cos y minus cos x into sin y divided by cos squared of a plus y. So what happens here? Dx divided by dy will be, please see, plus y minus y cancels. You get sin a divided by cos squared of a plus y. But you want dy by dx, not dx by dt. So I write dy by dx is equal to take reciprocal on both sides, cos squared of a plus y divided by sin a. This is the answer. Hope you have understood this problem. Cos y is given as x into cos of a plus y. You need to prove that dy by dx has cos square of a plus y divided by sin a. So we define for x cos y divided by cos of a plus y. Since x is a function of y, we differentiate that with respect to y. Dx by dy we take cos of a plus y into minus sin y minus cos y into minus sin of a plus y divided by cos of a plus y the whole square. So remember, there we have formula sin x into cos y minus cos x into sin y, where x is a plus y is y itself. Sin x cos y minus cos x sin y will be sin of x minus y. So sin of a plus y minus y divided by cos square of a plus y, y gets cancelled. Dx by dy will be sin a divided by cos square of a plus y. When you take the reciprocal, dy by dx will be cos square of a plus y divided by sin a. So that's what the answer you get. You have understood this problem. So we move on to the next problem. It's given if root of x by y plus root of y by x is equal to a, prove that dy by dx is equal to y by x. This is what required to prove. Dy by dx is equal to y by x. So this is the question given. Let us write squaring on both sides. What happens when you square root of x by y plus root of y by x, the whole square is equal to a square. X by y plus y by x, 2 root x by y into root y by x is equal to a square. Now root x, root y cancels. X by y plus y by x plus 2 is equal to a square. Now we need to differentiate this. Differentiate this denominator derivative of numerator minus numerator derivative of denominator y dash divided by denominator the whole square. It is y square. Plus again you have to differentiate this. Apply quotient rule. Denominator derivative of numerator minus numerator derivative of denominator by denominator the whole square. Derivative of 2 is 0, constant. Derivative of a squared is also 0. Now what we can do here is we can take x squared y squared as LCM. When we take x squared y squared as LCM, so y squared x squared y squared by y squared cancels. You will be getting x squared into y minus x into dy by dx. That dy by dx is written as y dash plus. So x squared divided by x squared y squared divided by x squared, we are left with y squared into x y dash minus y is equal to 0. Just cross multiply. 0 into x squared y squared is 0. Multiply x squared y minus x cubed y dash plus y squared x y dash minus y cubed. That's what 0. Now you can take y dash as common factor, x cubed. When you take y dash as common factor, xy square minus x cubed you get. To take all the other terms to RHS, you will be getting y cube minus x square y. What is y dash? Dy by dx. So here we take y as common factor, y square minus x square. Denominator, here cross multiply, we take x as common factor, y square minus x square. So now what happens? Y square minus x square cancels, you are getting y dash. That is nothing but dy by dx is equal to y dash. That's what the answer required. You have to prove dy by dx as y x. So hope you have understood this problem. So first step is to square it. We use the formula a plus b the whole square. So it is a squared plus b squared plus 2ab. You know 2 and a squared are constants. So differentiate x by y and y by x using quotient rule and simplify. So it's very simple. Hope you have understood this problem. Sine of x plus y plus is equal to log of x plus y. If sine of x plus y is equal to log of x plus y, prove that dy by dx is equal to minus 1. That is the important question. See here, first we need to differentiate this. Differentiating with respect to x. What happens here? Derivative of sine of x plus y is cos of x plus y into derivative of x is 1, y is dy by dx. Hope you have understood this. Now, log of x plus y, you consider this as log x, 1 by x into derivative of x plus y. What is the derivative of x? It's 1. Derivative of y is dy by dx. Now bring it to LHS. Cos of x plus y into 1 plus dy by dx minus 1 by x plus y into 1 plus dy by dx is equal to 0. From these two I can take 1 plus dy by dx as common factor. When you take that as common factor, you will be getting cos of x plus y minus 1 by x plus y is equal to 0. This term cannot be 0. So cross multiply. 0 divided by anything, that's 0. So that you get 1 plus dy by dx is equal to 0. Hope you have understood. Equate the first term to 0. Second term cannot be 0. So you cross multiply. 0 divided by whole thing, 0. What is dy by dx now? Dy by dx will be equal to minus 1. Hope you have understood this problem. Sine of x plus y is equal to log of x plus y is the problem. We have solved this problem in simple method. Next. If root x plus root y is equal to 1, find dy by dx at 1 by 4 comma 1 by 4. This is what the question is. If root x plus root y is equal to 1, find dy by dx at 1 by 4 comma 1 by 4. I differentiate to get 1 by 2 root x plus 1 by 2 root y into dy by dx is equal to 0. Differentiation, derivative of root x is 1 by 2 root x. Derivative of root y is 1 by 2 root y. Now, I write it as 1 by 2 root y into dy by dx is equal to minus 1 by 2 root x. So, what is dy by dx then? Minus 2 root y divided by 2 root x. 2 gets cancelled. What is dy by dx? Minus root of, what is y given? 1 by 4. What is x given? 1 by 4. So because you want dy by dx at 1 by 4 comma 1 by 4, you get minus 1 by 2 divided by 1 by 2. Those two gets cancelled. You get the answer as minus 1. You have understood this problem also. Root x plus root y is 1. Then you have to find out dy by dx at 1 by 4 comma 1 by 4. Is given e power x plus e power y is equal to e power x plus y. Find dy by dx. Find dy by dx. Very simple. Let us write e power x plus e power y is equal to e power x into e power y. E power x plus y can be written as e power x into e power y. Dividing throughout by e power x into e power y. What happens when you divide it? E power x divided by e power x into e power y plus e power y divided by e power x into e power y is equal to e power x into e power y divided by e power x into e power y. So here you get 1 by e power y plus 1 by e power x is equal to 1. E power minus y plus e power minus x is equal to 1. That's what the answer you get. So now you differentiate. Instead of differentiating in the first step, it is better you differentiate now. What happens when you differentiate? Derivative of e power y is e power y. Derivative of minus y is minus 1 into dy by dx. Derivative of e power minus x into 1 is equal to 0. Minus e power minus y into dy by dx is equal to, you take it to RHS, minus e power x. What is dy by dx? E power minus x divided by minus e power x. Now, to take it to the numerator, e power y by e power x, further minus e power y minus x. That's what dy by dx is. Very simple and easy way to solve this problem. But the only thing is, the first step, you need to simplify and then differentiate, not differentiate and simplify. Here first simplify and then differentiate. It reduces to a simple form like this. E power minus y plus e power minus x is equal to 1. The same way we have one more problem. 2 power x plus 2 power y is equal to 2 power x plus 1. This is what the question is. You need to find out dy by dx first. What is the first step? 2 power x plus 2 power y is equal to 2 power x into 2 power y. I write. A power m plus n is a power m into a power m. Next, let us divide. Dividing both sides by 2 power x into 2 power y. What happens? Similar to the previous problem, 1 divided by 2 power y plus 1 divided by 2 power x is equal to 1 unit. 2 power minus y plus 2 power minus x is equal to 1. So this is the simplest form in which the problem is in. Now we can differentiate. You know the derivative of a power x. What is the derivative of a power x? A power x into log a to bc. Now, what is the derivative of this? 2 power minus y into minus log 2 to base e into dy by dx plus 2 power minus x into minus log 2 to base e is equal to 0. Derivative of 1 is 0. Now, minus 2 power minus y into log 2 to base e into dy by dx. To take it to RHS, 2 power minus x into log 2 to base e. What is dy by dx now? 2 power minus x into log 2 to base e divided by minus 2 power minus y into log 2 to base e. So log 2 to base e cancels. What is dy by dx now? Minus, it is 2 power y divided by 2 power x. It goes to numerator, becomes 2 power plus y. 2 power minus x comes to denominator 2 power x. So minus 2 power y minus x is the answer. Hope you have understood both the problems. Only step important is you need to divide both numerator and denominator, both sides by e power x into u power y into first problem. But in the next problem, 2 power x into 2 power y, we need to divide. Next, y is equal to x cos y. This is what the problem is. You need to find out dy by dx. So differentiate. Dy by dx is equal to x into derivative of cos y minus sin y into dy by dx plus cos y into derivative of x is 1. So dy by dx plus x sin y into dy by dx is equal to cos y. Now we can take dy by dx as common factor. We will be getting 1 plus x sin y is equal to cos y. So what happens dy by dx now? Cos y divided by 1 plus x into sin y. Hope you have understood this. This is what dy by dx, we have got it in terms of y. If you want to simplify further, please see here, the RHS I write y is equal to x cos y you have. Cos y can be written as y by x. See, cos y you can write it as y by x. 1 plus x into, what is sin y? See, sin y can be written as a root of 1 minus cos squared. This is 1 minus y squared by x squared. What is that? Root of x squared minus y squared by x squared. What is sin y further? Sin y can be written as root of x squared minus y squared by x. So, sin y can be written as root of x squared minus y squared divided by x. So, x gets cancelled. What is dy by dx here? Dy by dx will be y divided by x into 1 plus root of x squared minus y squared. So, this is what the answer is. Hope you have understood. This is what we get. Everybody will do up to this stage. But remember, cos y should be y by x, and we can finally write it in terms of x and y. Suppose if they ask you to prove this, then you have to do all these steps. Otherwise, you can stop at this stage. Similarly, we have one more problem. Y is equal to x tan y. You have to find out dy by dx in terms of x and y. See, y is equal to x tan y. It is given. Now, let us differentiate. So, dy by dx is equal to RHS, you have to apply product. First function, derivative of the second, secant square y into dy by dx. Second function, tan y, derivative of the first is 1, x is 1. Dy by dx minus x into secant square y into dy by dx is equal to tan y. I take dy by dx as common factor, 1 minus x secant square y is equal to tan y. What is dy by dx then? Tan y divided by 1 minus x into secant square y. This is over. Up to this stage it is over. Since they want answer in terms of x and y, so see here on the RHS we calculate y is equal to x tan y you have. What is tan y? Tan y is equal to y by x. Tan y we can substitute y by x. Okay. 1 minus x into, what is secant square y? See, secant square y is 1 plus tan square y. 1 plus tan y is y square by x square. If you take x square as LCM, it is x square plus y square. So what is secant square y? Secant square y is x square plus y square by x square. So 1 plus tan square theta is secant square theta. So I write it as x square plus y square divided by x square. X gets cancelled. You get y by x. You take x as LCM, x minus of x square plus y square. Hope you have understood this. X cancels. What is dy by dx? Y divided by x minus x square minus y square. This is what the answer. So we get the answer dy by dx as y divided by x minus x square minus y square. Since you want answer in terms of x and y, we have solved this. So hope you have understood all these problems. So few problems will be given as homework. Please solve those problems. Find dy by dx if y squared into 2 minus x is equal to x cube. X cube plus x squared y plus xy squared plus y cube is equal to 81. 2x squared plus 3xy plus 4y squared is equal to 24. Further, ax squared plus by squared is equal to sin x power 2 by 3 plus y power 2 by 3 is equal to a power 2 by 3. Further, xy plus y squared is equal to tan x plus y. Please try to solve these 6 problems. Students, in this class we have studied, have understood how to solve problems on implicit functions. So we know what is the definition of implicit functions, and you know how to find the derivatives of the implicit functions. So please solve all these problems again and solve all the homework problems. That's all for the day. Thank you.